Okay, so if the equation x cube plus ax square plus bx plus 216 equals to 0 has three real roots in GP, then b by a is equal to, fine. So alpha beta gamma is negative 216, but we know that because these three roots are actually in GP, you can have alpha beta is equals to alpha gamma equals to beta squared. So beta cubed is equal to negative 216, which is negative 6 cubed. So because we don't want to be looking for complex solutions, just have beta equals to minus 6. Okay, so beta equals to minus 6 uh, looks correct, right? So what is b by a equal to in that case? Fine, so what is b? Our b is alpha beta plus beta gamma plus gamma alpha, right? And our what is this thing, right? And what is our a? Our a is negative of alpha plus beta plus gamma. Okay, cool. And we know that beta is negative 6, so this will just like b will turn out to be negative 6. um yeah, okay, negative 6 alpha plus gamma. Okay, maybe that's not where we should be going. Okay, let's just do it. So alpha plus gamma plus, well, what's alpha gamma? Alpha gamma is just beta square, which is negative 6 squared, which is negative 6 of, actually just put it like this, plus beta squared, which is once again negative 6 beta, I think, right? Because beta is negative 6, so that's for sure correct. So alpha plus beta plus gamma, which means that our b is actually 6 times a, so b by a turns out to be 6. Very easy, right? So this is equal to 6. Okay, let's move on. So given ABC, um, ABC are in AP and BCD are in GP and CDE are in harmonic progression. If A equals to 2 and E equals to 18, then the sum of all possible values of C is, okay, so ABC are in AP. That means that B is the arithmetic mean of A and C. So A is just 2, so B is actually equal to 2 plus C upon 2. Okay, fine. And then what else do you have? You have that BCD are in GP, so C squared is equals to B times D, fine. And CDE are in HP, so D is equals to 2EC upon E plus C, but we know what E is, it's just 18. So 2 into 18 into C upon 18 plus C. So now we can put these values of D in terms of C into this equation. So that will give me C squared is equals to 2 plus C upon 2 into 2 into 18 into C upon 18 plus C. This cancels, and then in fact this also cancels. C cannot be 0 because then the harmonic progression thing doesn't make sense because the reciprocal would be undefined. So right, so you will have C is equal to 2 plus C into 18 upon 18 plus C. Okay, so let's simplify that thing. So simplify this thing, you will have 18C plus C squared is equal to 36 plus 18C. So this cancels. So C squared is equals to 36. So C equals to plus or minus 6. In other words, the sum of, so in that case, the sum of the possible values of C, that will be 0. And notice that plus 6 and minus 6 both will actually satisfy all the conditions and are completely applicable. So yes, the sum will be 0. Okay, so the next question is if a plus ar1 plus ar1 squared all the way to the infinite terms, and a plus ar2 plus ar2 squared till the infinite terms be two infinite series of positive numbers with the same first term, then the sum of the first series is r1 and the sum of the sum of the second series is r2. Then the value of r1 plus r2 is, fine. So you are basically given this equation: a upon 1 minus r1 is equal to, and a upon 1 minus r2 is equal to r2. So it's almost like r1 and r2 are the roots of this equation. A upon 1 minus x is equal to x. So this is actually the same thing as saying a equals to x minus x squared. So x squared minus x plus a is equal to 0. So from that we can say that alpha plus beta is 1, but we know what alpha beta are. Those are actually just r1 and r2. So r1 plus r2 is equals to 1. So yeah, that's it. That's the answer. R1 plus R2 is 1. Okay, so the next question is for a and b greater than 0, let 5a minus b, 2a plus b, and a plus 2b are in AP. So that means 4a plus 2b is equal to 5a minus b plus a, that's 6a minus b plus 2b is plus b. That tells me, wait, minus b plus 2b is obviously plus b, and then plus 2b over there looks correct. So that tells me b is equal to 2a. Let's just check this first of all. So yeah, that's minus b over there, and this is supposed to be 2 of that thing. So these are in AP. So you got this condition 4a plus 2b equals to 6a plus b. So b equals to 2a, right? And the other condition is that b plus 1 squared, ab plus 1 and a minus 1 squared are in a GP. Then the value of a power negative 1 plus b power negative 1 is, right? So you have this thing, ap plus 1 squared is equal to b plus 1 squared into a minus 1 squared, right? So I could actually expand this thing on the left and right and then solve it and rearrange it to factorize and do something with that, but I'm not going to do all of that stuff, because what we can do is that we can just make two cases of this equation. Case 1 will be if a is bigger than or equal to 1. Notice that would make this thing positive and these two things are already positive. So if you take the square root on both sides, that will be like a plus ab plus 1, which is a positive quantity, is equal to b plus 1 into a minus 1, which is another positive quantity. So that will give me ab plus 1 is equals to ab plus a minus b minus 1. So this cancels and you will have a is equals to b plus 2. Okay, or what else could you do? You could take, okay, let's just solve this first. So a equals to b plus 2, but at the same time b is actually 2a, so a equals to 2a plus 2. So that tells me a has to be equal to 2, and yes, it actually falls under this thing, so that's correct. 2 is obviously bigger than or equal to 1, and that actually tells me b has to be 4. So a equals to 2 and b equals to 4 is a solution, right? So that's nice. You got 2 comma 4 is a solution. And then let's just look at the other case where a is less than 1. So if a is less than 1, you can open this like ab plus 1 is equals to b plus 1 into 1 minus a, because we want this to be positive, right? So that will give me ab plus 1 is equal to b minus ab plus 1 minus a. So 2ab is equal to b minus a, right? And let's put b equals to 2a over there. So that will give me 4a squared is equal to a. So either a can be 0 or a can be 1 by 4. So in fact these will also work kind of. um yes, so 1 by 4 is obviously less than 1, and then 0 is obviously less than 1, so these also work. Wasn't expecting that to come out, but fine. And then a equals to 0 will give me b equals to 0. uh okay, and what are we given? A, B are bigger than 0, so actually this cannot work. Sorry, this is not going to work. And a equals to 1 by 4 will give me b equals to 2 times of that thing, which is 1 by 2. So 1 by 4 comma 1 by 2, that will also be a solution. So this is also a solution. And yeah, let's just check it out if it's a solution first of all. So like when you put 1 by 4 over there, this equation is obviously true, so don't worry about that thing. And then just put 1 by 4 and 1 by 2 into this original equation. That obviously is satisfied because we actually solved it to get this equation. So yes, that's correct. In fact, that is also applicable solution. So right, 1 by 4 and 1 by 2, and where was the other one? 2 and 4, these will be the two solutions. And where given ab is bigger than 0 are in GP, then the value of a power negative 1 plus b power negative 1 is. So either it could be 2 plus 4, or it could be 1 by 2 plus 1 by 4. And I think that it should really be 2 plus 4 over there, because we want integers as our answer. So 2 by 4 is 6. So that would be our answer in that case. Right. Yeah, that looks correct. That looks correct. No problem, right? B in AP and these are in GB. But in fact, 1 by 2 plus 1 by 4 can also work, which would be 3 by 4. So 6 or 3 by 4 should be the answer technically, but because we only want integers as our answer, I think 6 would be it. Okay, so the next question is, the first term of an arithmetic progression is 1, and the sum of the first 9 terms is equal to 369. Okay, so the first term of an arithmetic progression is 1, and the sum of the first 9 terms is 369. So you have 9 upon 2 into 2a, which is just 2 plus 8 into the difference is equal to 369. Okay, that's like 9 into 1 plus 4d is equal to 369. So 1 plus 4d is equal to, this thing upon 9 is just 41. So d has to be 10, right? We know the difference is 10 and the first term is 1, right? The first and ninth term of a geometric progression coincide with the first and the ninth term of the arithmetic progression. If the seventh term of the geometric progression is t7, then the value of t2 by 9 is, oh, I think it should be t7 by 9 in that case, because t2 is not yet defined. Fine, so I think it should be t7 by 9. Right. Right. Okay, so what are we given is that you got these numbers. The first term is 1, and then the difference is 10, so this will be like 11 and then 21 and so on, till you eventually get the ninth term, which will be 81. And then over here also you have 1 and 81, and then there are some terms between those, and this is like the ninth term of that geometric progression. Okay, and then we want to find what is t7 upon 9, where t7 is the seventh term of the geometric progression. So this will be like t7, t8 and t9. So just need to go down by r squared, I think, right? So just calculate what r is supposed to be. So you will have r power 9, 9 or 8, I think 8, right? Because you want to make 8 jumps from the first term to the ninth term, so r power 8 is 81. Okay, so r is going to be 8th root of 81, actually plus or minus of that thing, but are we given anything coincide to the first and ninth? Okay, it doesn't matter if it's positive or negative, because in any case we are going to get that r squared is a positive value. So r squared is the fourth root of this thing, so that will be 3, right? So r squared is 3, therefore t7, which is just t9 upon r squared, that is, well, what's t9? T9 is 81 upon r squared, which is just 3, so that's actually 27, right? That's the answer. T7 is, oh wait, we want to find t7 upon 9, so like t7 upon 9 is 27 upon 9, which is just 3, so 3 will be the answer, right? So the next question is, uh, the value of this sum from n equals to 0 to infinity of 2n plus 3, or it's another arithmetic or geometric series. Fine, let's just do it. So let's start. So s equals to, when you put 0 over there, you get 3 into nothing, and then when you put 1 over there, you get 5 into 1 by 3. When you put 2 in there, you get 7 into 1 by 3 squared, and so on, right? So maybe just multiply this s by 1 by 3, so you will get 1 by 3 s is equal to 3 into 1 by 3 plus 5 into 1 by 3 squared, and so on. So if I subtract that, I will get 2 by 3 s is equal to 3 plus 2 into 1 by 3, right, plus 2 into 1 by 3 squared, and so on. So that will be like 3 plus 2 by 3. upon 1 minus 1 by 3, because this sum is like an infinite geometric series. Okay, so that will be 3, and this thing is just 2 by 3 itself, so it's like 3 plus 1, so 2 by 3 s is equals to 4, so s has to be 6 in that case. Right, that's it. This sum is going to be 6. So that was it. This was the last question, I think. Thanks for watching, and I'll see you in the next video.